Andrew Ng, founder of DeepLearning.AI, and I'm excited to welcome you to our global deep learning community. I know that many of you are here today because you want to break into AI and build your career. I hope that being part of this community will help you to do so. To give you a proper welcome, I'd like to show you around the DeepLearning.AI offices and meet some of the teams so that you can see where it all happens.
Oh, hi, Andrew.
Do you want to tell our friends at Pine AI what you do at DeepLearning.AI?
Sure. Hi, everyone. I make articles and other media that help people learn about AI and help them understand the huge impact that AI is having in the world. Today, I'm putting together the next issue of The Batch, our weekly newsletter, and I'm looking for the biggest stories of the week to keep our readers informed.
What's been the most surprising thing you've run into working on the batch?
How much is going on in this field? There's never a dull moment. You know, you might think from the outside that machine learning engineers really understand everything about AI, but nobody understands everything about AI because this field is just coming to life right before my eyes as I put this thing together every week.
All right, I know you're really busy, so I'll let you get back to it.
Thanks. See you later.
Let's go meet Kian, who helped me create the deep learning specialization. He's working on an exciting new project. Hey Kian, so do you want to tell the people at Pine AI what you're working on?
Yes, sure. I'm leading a project called Wortera, focusing on helping people get offers in AI and navigating their career by testing their skills, preparing for interviews and certifying them, as well as matching and referring them to good jobs in AI.
That's really cool. And what's the most exciting part of your day?
You know, the AI field is new, organizations and jobs are still misunderstood. So I'm excited to help people understand what different types of jobs exist in the field, what tasks they will work on, and what skills are needed to achieve those tasks.
That's really important work. Well, it's nice chatting. And now let's go chat to Hotel, who is on their product team.
Hey, Andrew.
Do you want to say hi to our friends at Pine AI and let them know what you're working on?
I would love to. Hi, everyone. I lead the product team in DeepLearning.AI, where we create AI education content accessible to people all around the world. People like you.
And what are you most excited about right now?
I am so excited to see our community grow and to see how eager people are to learn more about AI.
Thanks, Hotel.
Thanks, Andrew.
So as you can see, our team is working hard to support you and help you learn. It's never been easier than before to break into AI. So if you want to build a career, you can leverage online resources available, including open source code, datasets, papers, and online courses like a deep learning specialization on Coursera. As part of this journey, I hope you get your hands dirty too. Don't be afraid of diving in to build your own project, or go ahead and try to replicate a research paper that you're excited about. One thing that I've seen help a lot of people succeed is if you can build a community or find a community of fellow deep learners you can meet with and study with on a regular basis. In fact, I hope that this Pine AI meetup that you're at right now will be a good place for you to meet these people. I hope you enjoyed the event today and that you learn a lot both from the talks and from each other. And once again, welcome to the DeepLearning.AI community.
So hello everyone, and my name is Debolina Mahapatra. I am a master's in technology first year student in the branch of computer science and engineering at National Institute of Technology, Patna. And my specialization is in information security, but I love to work in AI, which is why natural language processing and AI are some of the areas that I just love to explore. And DeepLearning.AI has provided us a really good learning platform, which enables us to just have a wonderful group of learners and online courses and a lot more. So let's begin today's session. So about sentiment analysis, a lot of you must have heard about. So it's used in market research, like it has been shown in surveys that people rely a lot on online reviews, and a lot of data available on the web is in the form of unstructured text. So that is why we need to process this text with the help of natural language processing and text mining techniques. So this is the agenda for today's session. First, I'll introduce you to what natural language processing actually means. Then we'll go through the task overview, the task of sentiment analysis, followed by some of the basic concepts like how to pre-process a text, then bag of words model, term frequency and inverse document frequency. It is a statistical measure which is used to construct features from text. So we'll also learn about that. And for the learning part, so since sentiment analysis is a mix of statistics, that is TF-IDF or count vector bag of words that you use. So we'll also have a mix of statistical techniques, then natural language processing and machine learning. As far as machine learning is concerned, I took the Naïve Bayes classifier, which is preferably a simple classifier to perform this task, and we'll finally implement this entire thing on Google Colab. So I hope you all are familiar with the Google Colab platform, but I'll first go through Google Colab. So basically, over here you have the Python notebook sort of environment, and it is completely free, and you can access it from your browser. So I request all of you that just open up a window of Google Colab in your respective browsers and just connect your drive. So I'll be sharing a link with you. And that link contains the data set which we are going to work with today. So you can directly copy the folder in which the data set is available and directly use it to work with it alongside as and when I teach it. Okay, so I'll just share the link with you all in the chat box. Yeah, so I hope you all have got the link of the data set, and that will help you to just directly use the link, copy the folder in your own drive and use the link. Okay. So for Google Colab, you can just go to colab.research.google.com, and over there you can connect with any runtime. So here I am connected to Google Compute Engine backend. And over here you have the option to connect with Drive. So just click on the option to mount the drive. You'll have an option to mount the drive. And over there you can simply just give the permission, and you can navigate your drive using this site column available here. And this is the way we are going to load the data set. So when the implementation begins, I'll let you know. But for the time being, just copy the data set to your browser, so to your Google Drive folder, okay? All right. So why do we need natural language processing is one of the most important questions. So a huge amount of information available today is stored in an electronic form over the web, and this is in an unstructured format. In order to derive some actionable insights from this data, we need to perform text mining techniques. And natural language processing and text mining go hand in hand. So it is kind of like text mining the process to derive some meaningful information from the text that you have at hand. And natural language processing enables you to combine it with AI techniques. So it is a branch of artificial intelligence that will deal with the interaction between computers and humans using natural languages. Also, natural language processing, it is divided into two branches: natural language understanding and natural language generation. So natural language understanding is kind of deals with the useful representation of language. That is, you analyze the language. It is in fact quite difficult because you have to map the given input into a natural language. Then natural language generation is the process of producing meaningful sentences and phrases in the form of natural language from some internal representation. So these are two main areas within NLP, the natural language generation and natural language understanding. So we'll get to know more about these in subsequent sessions, but this is all for now. And we also know that a lot of applications of NLP exist in in today's world. Uh, so like sentiment analysis is one of the most popular applications of NLP, followed by speech recognition. Like day-to-day life, we use Google Assistant, then Apple Siri we had, then a lot of Amazon Echo, probably, yes, speech recognition, and a lot of other applications that are being developed continuously. And continuously, we are also incorporating these applications in our day-to-day life. And chatbots are pretty common these days. Even in online shopping websites, you most often interact with chatbots until and unless the chatbot fails to answer your query, and then you have to actually speak to a human. And then you also have machine translation, which can be achieved using natural language processing, like translating from text in one language to the other. Information retrieval is a very old application, to be specific, because as you know, Google is a search engine which is actually based on information, which is information retrieval. So you are searching within a huge corpus of documents available, stored at some point in the web, and you are accessing the required information from within that corpus. So that is information retrieval. Then you also have information extraction. So you are given a text and you want to extract some specific information from the text. For example, when you perform a Google search on the web, then you must be seeing nowadays that a small summary crops up on the top describing the entire thing that you are looking for. So it's kind of an application of information extraction as well as text summarization, you can say. And we also have question answering systems. So these are very popular, and a lot of work is being going on in NLP. And much recently, NLP community is being has actually moved to deep learning. So you have latest applications like BERT is one of the very good models for natural language processing that has been developed by Google. So natural language processing has a lot of scope, and with the advent of deep learning and how it merges well with deep learning, so a lot of research is being done in this area. So these were some of the applications which I have highlighted over here. Next, we shall focus now on the application that we are going to study today. So, sentiment analysis helps us to identify the opinion of an author towards a topic. So, you must have seen that on shopping websites on the web, that customers post a lot of reviews. So, how can someone analyze each and every review independently? So, in that case, sentiment analysis is a very powerful tool which helps you to get the overall score of a particular product by analyzing the customer reviews. So, here I have given an example. So, three different customer reviews you have on your screens. And the first customer review is totally a negative, expresses a negative sentiment. Then the second one is neutral because good job, but I expect a lot more in future. So that is kind of a balancing aspect. So that is why it is a neutral sentiment. And the last one is a positive sentiment. So you can analyze the text because we are humans and we are simply reading the text. We understand our language, but a computer operates in binaries and numbers and it cannot understand what we humans are communicating. So the language that we use to communicate with each other, that is our natural language like English or Hindi or Bengali or Spanish or French. So these are natural languages that we humans use to communicate with one another. And it is difficult for a computer to understand these languages. So we have to convert them into certain representations and we have to use statistical techniques, or we have to model the text in such a way and feed them in a way so that the computer can understand it. So now we will be seeing how to do that as well. And in this particular session, we shall be performing sentiment analysis on a data set of IMDB movie reviews. So in this data set, we are given around 10,000 movie reviews, and it is a binary classification task. So binary as in we have only two sentiments available in the data set, either positive or negative. And a task is to train a machine learning model to automatically classify the sentiment of a review. And we shall learn about two different techniques. The first is bag of words model for feature creation, and we will also learn about term frequency and inverse document frequency feature vectors. Okay, so yeah. So this is before beginning anything, this is the most important foundations of natural language processing, which is your text pre-processing pipeline. So learning algorithms like machine learning algorithms, they need some well-defined input, and input should be in a structured format. So we have to model our text in such a way that these statistical algorithms can work with them, because they cannot understand text. We cannot feed in raw text to a machine learning model. So we need to model the text as a vector of numbers. So in a numeric form, we represent the text, which is then fed to a machine learning model, which then can understand the text, manipulate the text using mathematical techniques and all the lot of things undergoing, and it can give you the output, the desired outputs that you require. So these are the steps involved in text pre-processing. So the first we have raw text, and we perform lowercasing. Lowercasing because we do not want any interference with the text, capital text. Like you can have the with th, t capital, and t small. So if you feed in raw text without lowercasing, then it will not be able to differentiate between the starting with capital T and the starting with a small t. So that is the problem, which is why we need to mitigate that particular issue by lowercasing the text. The next thing is we want to perform punctuation removal. And why is it so? Is because punctuations do not hold any semantic weights, as in our case at least. For sentiment analysis, we are not going to use punctuations. So we want to remove all those things which do not have any meaningful representation or any meaningful aspect for a machine learning model. So after lowercasing, after punctuation removal, we are going to perform tokenization. So tokenization is actually dividing a sentence into tokens, or we can say individual words. Suppose we have suppose we have a sentence like steps involved in text preprocessing. So when you perform tokenization, the word steps is one token, involved is one token, in is one token, text one token. And if you perform punctuation removal, then pre will be one token and processing will be one token. So in that way, we will have a list of tokens after performing tokenization. The next thing that we do is stop word removal. Now, stop words are words which are having very less semantic weight. So they are not really important for a machine learning model. And stop words include words like and, or, the, a, and all those things. So those words are not really important in identifying the sentiment of a sentence. So stopword removal becomes essential. And after that, we shall be performing stemming. Stemming is a technique of reducing the inflectional endings of a word. So that means that if we have, if we have a word playing, playing, player, and plays, so stemming will chop off the last ends of the word. So what we will end with is play after stemming. So it will reduce the word player to play, plays to play, and playing to play. So it actually kind of normalizes the text, we can say that a lot of variations in text is there, but the root word, what is the root word of a particular variation? So stemming helps us to obtain that root word from which the other words have originated. All right. So these are the basic steps of text pre-processing, after which we can find the list of pre-processed tokens, which are actually ready for further feature construction. So before I go for feature construction using bag of words, I'll just quickly go through the implementation of text preprocessing. Um, is my Google Colab screen visible? Just
Yes,
anyone respond? Yeah, okay. Okay. So we are going to use pandas for working with data frames, and I'm assuming that most of you are acquainted with the basics of Python. So pandas is a library which helps you to manipulate data frames, and data frames are sort of tabular format of data. So data is present in rows and columns. It is a data structure which is present in Python. So this is the way we are going to access data. So like I said, the folder which I have shared with you, which is available in Google Drive. So you can simply get the link of the CSV file, the IMDB dataset, and copy it down to pd.read CSV and given the link. So that will help you to load the data. And after that, you can just print the shape of the data. You can see it's 50,000 reviews, and we have two columns. Okay, so this is the structure of your data set, which is the review and the sentiment, corresponding sentiment, which is either positive or negative. All right. So if you want to see what is the kind of text available in the particular review, so over here you have a positive review, but you can see there are a lot of HTML tags available over there, and a lot of punctuation marks as well. So these are certain things which need to be eliminated in order to go through the text properly. And this is a negative review, but the same thing. It is difficult for you to read the entire review. So we will go for generating word clouds. So it is an interesting thing. It's quite fun. So you can just take one particular review, and we have a particular library in Python, the word cloud, and it helps you to generate word distribution kind of thing. Okay. So here we have a positive review, and we are trying to generate a word cloud, and this is the way it comes. So you can see the occurrence of words. So just because we have HTML tags appearing quite a lot, so the word BR is also appearing in the word cloud. Other than that, we have the words well, realism, then Yeah, peace, sense, filming, comforting. So this one is the positive review and word cloud, and this is the word cloud for the negative review. So it's like a drama, little drama and movie. So it's just a way to just visualize the movie review, the word distribution in your movie reviews. Okay, so let's now go on to text preprocessing. So text preprocessing fundamentally consists of the following steps. So we'll perform lowercasing, punctuation removal, tokenization, stop word removal, and stemming. And we are going to use the NLTK library for this purpose. So NLTK is Natural Language Toolkit. It's a Python library, and it has a lot of functions which you can use to manipulate your text. So, and we also have the regular expressions library, which helps us to regular expressions library that you can use regular expressions to just manipulate your strings. So that also comes handy. And these are some of the things which you need to do in Colab just to create the environment. So for particularly in Colab, that becomes a problem. So if you have your own NLTK installation, then you will need to do that. And we have the different libraries uploaded over, imported over here. Then this particular list contains the stop words, all the stop words in English. So you can see that you can simply see I, me, myself, we. So these are the different stop words in English which can be loaded directly from NLTK. And we also have the list of punctuations which we can import from the punctuation string.punctuation function from the string library in Python. All right. So first we perform a lower casing of the review column in our data set. So we use the aggregate function, and then we use over here I have used regular expression to remove all the non-alphabetical characters. So non-alphabetical would also remove the punctuation, the numeric, and any other character which does not lie between A to Z. So all those characters will be removed. So after that, I have a cleaned review over here. And here you can see a lot of less, so kind of really clean. And after that, we shall be applying the tokenization. So tokenization you can do in two ways. So you can directly use string split function of strings, but over here I've used the word tokenize function of NLTK. So when I apply the word tokenize function, then this is the way. So you feed in the entire string. Basically, there's a family where a boy Jake. So this entire string you feed in, and this is how it splits the the whole string into a list of tokens. So here you have your entire list of tokens. And now we shall be performing stemming and stop word removal. So a lot of stemmers are available in Python, but over here I have used Porter stemmer. It's kind of conventional stemmer. And here I have performed stemming as well as stop word removal in a single function. So whatever word is not a stop word and is not a punctuation. So in case anything cropped in, so it's not necessary, but okay, it's over here. And stemmer.stem, so this is a function. So you initialize your stemmer to be Porter stemmer, and then after you have created an instance of the stemmer, then you can call the function to perform stemming on that word which is not a stop word. So like that you can filter out the words, and then you can get your clean reviews. So here we have the clean reviews in which we do not have any sort of stop words or punctuations. All right. And one thing which you can do is you can save this entire cleaned reviews file to a pickle file. So a pickle file helps you to maintain these intermediate processing. After intermediate processing, you can maintain these intermediate files as a pickle file. So you don't have to, if you want to run the code again, then you don't have to perform the entire pre-processing all over again. You can simply just go to your drive and you can have that pickle file. Just load it all over again. So you have the function pickle.load, and after that you can get your file. So that is a good approach to save all your intermediate files. All right. Okay, so now we shall go forward with feature construction. Okay. So bag of words model is one of the most primitive, actually, a primitive way to express the text, and it is very popular, and we consider each word count as a feature. So the frequency of each word in the document will be stored, will be computed, and that will be used in order to construct the features. And the more frequent a word, the more important it is. So that is the approach to bag of words model, that the word which has most which occurs more times, that will have the more weight. And this is a good way to determine the significant words in a text, so that you can see that the word which is occurring a lot of times within your text, so that word gets more importance. So over here you have a corpus present. So the corpus contains 3 sentences. The lion is the king of the jungle. The lion is an endangered species. Lions have lifespans of a decade. So this is a collection of 3 sentences within a corpus, but okay, so but our corpus is actually composed of 50,000 movie reviews. So this is a very small corpus, which is just over here to demonstrate the usage of bag of words. Okay, so first of all, we form a vocabulary. So a vocabulary consists of all the unique words in your corpus. So over here you can see A and decade, endangered, have, is, jungle, king, lifespans, and so on. So there are a total of 15 words in the corpus, unique words, and all those unique words form your vocabulary. And over here you can also see that no pre-processing has been performed. So the A and is, so words like these, the stopword removal, nothing has been done. It's just a simple corpus. Okay. And if you want to represent the sentence, the lion is the king of the jungle, in a bag of words vector form, then this is the method that for every vocabulary. So if you have the vocabulary size as 15, then the length of your vector will also be with 15. And the vocabulary consists of the list of all these words, and you have to put the frequency in the position of the word. So the first 0 over here represents whether the word A occurs in the sentence or not. So for this you can see A and decade, endangered, have, is. So after all these words have passed, you can have a 1. So for 1 stands for is, because we have the word is in the sentence lion. The lion is the king of the jungle. Similarly, you can see from the second last part of the list that the word the appears twice in this sentence with a small letter t. So the word the appears twice. So from the second last element of the vector is 2. So that is how the frequency is formed, and that is how your bag of words vector works. Okay, so you will take the entire vocabulary as a particular arrangement, and wherever the word is occurring, you will put the frequency. So first you have the vocabulary, the size of the vocabulary 15. You take the cell sentences separately. So the lion is the king of the jungle becomes one sentence. Its representation will be in a vector having the size of the vocabulary, which is 15 over here, and whichever words are occurring in the sentence, you will place the frequency within the vector in the respective positions. So that is how your bag of words vector formation will be done, and this particular vector will serve as a feature vector. So this will be fed to your machine learning model. All right. So, okay, and apart from bag of words vector, we are also going to work with TF-IDF, which is a statistical measure that helps us to determine how important a word is to a document in a collection or corpus. So, actually, a bag of words vector attaches importance to the frequency. All right. So, frequency, like the word which appears maximum number of times, will have more importance. But what if the word is not really generalizing the entire corpus? So that becomes a problem. So in TF-IDF, there are certain words, like if you have a shared corpus, so shared words beyond just stop words. Okay, so stop words are the frequently occurring ones, but if you have a word which is occurring a lot of times in all of the documents, so that should not have that much importance, because that is also a frequently occurring word, but it is not semantically important. So what TF-IDF does is it uh, it will highlight those words which are document specific. Okay, so it ensures that all those document specific words that are occurring frequently, they will have a higher weight, and the words that are common across the entire corpus, their weights will be decreased or down weighted. So this is a different kind of statistical measure, which is actually different from bag of words, which you saw just now, that the frequency will be normalized across the entire corpus. So in TF-IDF, all the words which are very, very unique, so in a particular document. So document specific means that in a particular document, if you have a certain word which is not found in other documents in the same corpus, then that word will have a higher weight. And the common words, the words that are occurring throughout the entire corpus in all the documents, those will be down weighted. All right. And this is the formula of TF-IDF, and it stands for term frequency, which gives you the percentage of the word compared to all tokens in the document. And inverse document frequency stands for the logarithm of the total number of documents in a corpora divided by the number of documents containing the term. So over here, TFIJ, the term stands for number of occurrences of token I in document J. So given a document, if you have to compute the TF-IDF weights of individual words, then you have to consider a specific token in the document and count its occurrence. After that, you have to take the logarithm of the total number of documents. So how frequent is that word occurring across all the documents in the corpus? So that also needs to be considered. So total number of documents divided by number of documents that contain the token I. So whatever token for which you are computing the score, you have to see in how many documents across the entire corpus is that particular token occurring. So that is the way in which the TF-IDF scores are computed. And if you want, you can take the previous corpus, which I discussed right now, and you can compute it on your own. So I'm not going to go in detail with the computation, but this is the way it works. So for you have to consider each and every token in the document, and you have to compute its score separately. That is why we have inbuilt libraries in Python. You can also code it on your own, but we have inbuilt libraries in Python, which helps us to perform this computation with just a single line of code, and it's very efficient. So yeah, and after TF-IDF, we will go for the model that we are going to use. So the two feature construction techniques that I discussed right now, bag of words and TF-IDF. So we will be comparing the performance of the two. All right. So first we will construct a bag of words feature vector. So yeah, this one, bag of words feature vector, and we will also construct a TF-IDF feature vector, and we will see how well the model performs with both of these. So like a comparative analysis kind of thing, and we shall be using Naïve Bayes model, machine learning model. So Naïve Bayes is actually a very popular model, and it's one of the most simple classification algorithms, and it uses the Bayes theorem for calculating probabilities and conditional probabilities. And it is also a supervised machine learning algorithm. So what happens in supervised is that you are given features and you are also given the corresponding labels. So if it were unsupervised, then in unsupervised you do not have the labels available. You have to analyze the patterns within the data using some you have clustering is an example of an unsupervised learning approach. But in supervised, we have the corresponding labels to the features readily available. So if you have the features X, you also have the corresponding labels Y, and that helps you to perform the unsupervised ML algorithm, to apply the unsupervised algorithm. And why is it called naive is because it makes the assumption that the features that we have are that we are going to use for classification, they are all independent, but that does not really happen. It's actually a rare case, but that is how naive Bayes works. It assumes that all these features are independent of each other. And below you can see it's the Bayes theorem. So I hope you are quite. I hope you are familiar with the Bayes theorem from probability or mathematics classes. So you have the conditional probability over here, and so conditional that uh, probability. So probability of probability of x given y is equal to probability of y given x multiplied by probability of x divided by probability of y. So I'm going to explain you with the help of a very simple example. All right. So it's a mathematical example, and you'll feel it's a probability example, but that's the core behind the working of Naïve Bayes. Okay. So this is a medical diagnosis problem. It's a simple problem based on two alternative hypotheses. So Naïve Bayes actually searches the most probable hypothesis in a given space of hypotheses. So suppose you have a hypothesis that a patient has a particular form of cancer, and a second hypothesis that the patient does not have cancer. So, and you have two possible outcomes, a positive and a negative outcome. And we have prior knowledge. We know that probability of the occurrence of cancer is 0.008 and probability of not having the cancer is 0.992. And you are also given that probability that the outcome is positive given the person has cancer is equal to 0.98, and probability that the outcome is negative given that the person does not have cancer is equal to 0.97. So suppose we have a new patient and the patient gets a positive result, and we want to see that okay, he has got a positive result, but does he have cancer or not? So is the test result correct or not? So if we want to evaluate that, we can compute it in this way. So we have two hypotheses, right? H1 and H2. And H1 states that the patient has a particular form of cancer, and H2 states that the patient does not have cancer. And now the task is to evaluate these two hypotheses. So H1 is, so this is how we compute the probability that probability of the hypothesis H1. So here we are using the Bayes theorem, probability that the result is positive given the patient has cancer multiplied by probability that the patient has cancer. So you can see that this is how we have evaluated both the hypotheses, and we found out that the result for hypothesis 2 is greater than hypothesis 1. So hypothesis 2 will hold. Therefore, the patient does not have cancer, although the lab result returned a positive result. This is the uh, core technique behind the Naïve Bayes algorithm. And when you are using it for text data, then what it does is that it will take the individual words and it will map it to the label and check that whether these words, it will compute probabilities in terms of your words. So for our task, we will be using the multinomial Naïve Bayes algorithm, and it actually works well with text data and text classification tasks. So whatever probabilities will be computed, these probabilities will be based on the occurrence of the words in the whatever feature vectors you're feeding in. It's like bag of words we will be feeding in, so it will compute probabilities in terms of that. So this was just a basic example of how a Naïve Bayes classifier works. So let's move on to the implementation. Yeah, so for bag of words, if you want to construct it, the first thing is in sklearn, you have this particular library called Count Vectorizer, which helps you to construct your bag of words vectors. And over here, we also have the train test split. So first, the first step is to divide your data into training and test set. So as to because you want to generalize it. All right. So whatever matrix of word vectors you are computing, so the vectorizer will first fit it on your train data. And after that, you want to see how well it generalizes on your test data. So by using that same vectorizer, you will apply it on your test data. So you will not fit the vectorizer on your test data. You will simply fit it on that train data. All right. So that is one of the most important things that you need to take into account, because what happens is that if you fit it all over train as well as test, then it will not give you a good generalization. The model will not be able to generalize well, because your vectors need to be taken into account by considering your train set. All right, so here I have used the train test split function, and the first parameter to train test split is x, that is your features, so data.review, and we have data.sentiment, which is the y, the labels, and I have kept the test size to be 0.30, which is 30% test size and 70% train size. And here random state, okay, so random state is used because we want to preserve the state. So if you mention a particular random state, like if you have random state equal to 42, then it means that every time you run your algorithm, so every time you split the data, then data will be split in the same way, it will not be shuffled. All right, so that is why random state variable is used, so if you want to preserve the state. And here we have the training and test set sizes, so 35,000 samples for training and 15,000 for test. So here I have initialized a vectorizer, and I have used max features equal to 10,000. So it will take only 10,000 most frequently occurring words. So those words which will have the values, the frequencies, all top 10,000 words will be taken as your features for the count vectorizer. So in bag of words model, you saw that we had the vocabulary, the entire vocabulary when we were taking, then it came to be 15. So size 15 vectors we were having over there. So over here, if we are taking max features to be 10,000, then we are going to have vectors of size 10,000. So 10,000 becomes our vocabulary size. Okay, and then we fit the matrix on X train and we transform. So transform function is used to form your bag of words vectors. So what vectorizer dot fit function does is that it computes the it computes your vocabulary. Okay, so the entire vocabulary will be based on your train set. And when you are computing the bag of words, then bag of words vectors will be based upon how your train set, what is the vocabulary present in within your train set. So here we have X-train bag of word feature vectors and X-test bag of words feature vectors. And it is also very important to note that this function returns a sparse matrix. So you have to convert your sparse matrix into a NumPy array in order to apply it to your learning algorithms. So over here we have, you can see that these are vectors of size of dimension 10,000 in shape, and we had 35,000 entries in our training data and 15,000 for our test data. This is how an array will appear, and it will consist of the frequencies of the individual words within the vocabulary of the entire training set. Okay, so over here we are using a multinomial Naïve Bayes, and as the reason I gave you that it performs pretty well with for your text data. For text classification tasks, this one is quite a popular approach. So we will first initialize the multinomial NB, then we fit it to our training data. So whatever bag of words vectors we got, we are going to use it as a features, and Y-train is the labels that you have. Then you perform prediction with clf.predict x-test bag of words, and then we want to evaluate how well our how well a model performs. So for that we use a confusion matrix. So a confusion matrix helps you to see the false positive rate, false negative rate, and you can evaluate it. So we take the entire diagonal, which helps us to get the accurate results. So 6,381 labels belong to class 0 and have been classified to class 0. So that is how we can see our confusion matrix. And if we want to print our accuracy score, then it comes to 84%. And you can also print the classification report, which gives you a little bit more in detail. So you have the precision, recall, F1 score. So all of the values that you can get over here. So for the respective classes. And if you want to use TF-IDF feature vectors, then you have, instead of count vectorizer, you have TF-IDF vectorizer. And similar to the previous approach, I've also used 10,000 max features equal to 10,000 to limit the size of my vectors to 10,000. So and then used the vectorizer to fit on the train data, and you generalize it. So how well does it generalize? You have to see in each step. So that is why we have X-train X-train vectorized to TF-IDF vectors. And again, you have to convert it to arrays, NumPy array, because again, it will return a sparse matrix. And when we perform classification using this technique, then we see that the accuracy comes around 83.6. So it's kind of near about here in this case, as per if we consider the multinomial Naïve Bayes, because it works in a probabilistic manner. So whatever weights are being computed, so they are kind of taken as in a probabilistic approach. So you can also apply a lot of other algorithms are there. So decision tree you can use and check if it performs the same way or not. And this is a very basic approach towards Naïve Bayes. using Naïve Bayes. But a lot of other high-level algorithms are available. For example, nowadays sentiment analysis using deep learning or sentiment analysis using neural networks was, as this is an introductory session, so I have used a simple classifier. Right. So putting it all together, whatever steps that we followed in the implementation. So first, we performed text pre-processing on the reviews column. Then we generated the bag of words representation for all the reviews. And we applied machine learning on the generated bag of words vectors, and here we have used Naïve Bayes. Next, we have also constructed TF-IDF feature vectors, and we have applied a learning algorithm on these generated vectors. And we have also compared the performance of bag of words and TF-IDF. We saw that the performance was more or less same in this case while using multinomial Naïve Bayes. But when we use different advanced feature construction, or if we use more advanced learning algorithms, then there can be quite a lot of difference in the performance. So thank you. Okay, and shall I go for implementation? Do we have time? Shall we go for step-by-step implementation alongside the participants? Hello? Okay, so do we have questions? Yeah, I'll share the collab link later. And I'm asking, we do have time left, so shall we go for the implementation alongside? Do you want me to share the code and you'll implement it side by side? Is that okay? Can we unmute the participants? If anyone can say in chat box. Yeah, all right. And all right. Okay. So has everyone downloaded that data set? Oh, sorry, linked it, copied the folder to your drive? Just raise your hand if it's all okay, if you have got the link and it's working fine. Okay. All right. All right. Okay, then go to the page collab.google.research. Just a second. Yeah, collab.research.google.com. Just go to that page, and in just a second, I'm catching up. Okay, so I have one question from Shivam Jha. So how to account for the biased nature of the data? Yes, so that is a problem because when we use statistical measures like TF-IDF or bag of words, then what actually happens is that it does not take into account the semantics. So as the word-to-word relationships, that is not being taken into account. So yes, there can be some bias nature. So if you have, for example, if you have sarcasm detection, then that cannot be performed using a TF-IDF because it's a purely statistical measure, mathematical measure. It is simply computing a formula, right? So you cannot go for such measures for all of the cases. But yes, this is a very introductory session. So I I used these very basic formulations. So bag of words and TF-IDF, these are very basic concepts in NLP. So it will not take into account the biased nature of data in text data, but for a preliminary application, you can use that. So here 5-star rating, again one more question by him. Okay, so 5-star rating. So that is the thing. Here we are analyzing the text. So here we are not taking this into account. So what is being conveyed by the opinion of the people? So what people are expressing in the form of text. So that is important. All right. So while analyzing the text, the rating is not rating analysis is a different aspect. Okay, but over here we are taking so if you have a product and you have a lot of reviews on that product, so you are considering the ratings on one side, so that is the data analysis part. But we are taking over here, we are considering the text. So how can we extract information from the text, and how can we analyze the text? So that is being done by using the sentiment analysis approach. If anyone has any questions, you can punch your queries in the chat box. Talk was that I wanted to show what features can we use, how can we construct these features, and how can we feed it to a machine learning model. But yes, this is just introductory one. No? So Naïve Bayes is actually very easy to understand and very easy to implement, and it's just based on the Bayes theorem. So it also does not take into account the interrelation between your features, the correlation. So it is just assuming itself that the x and y are independent of each other, right? So the features are independent of each other. That is not the real case. So that does not happen. The features there lies some underlying correlation is always existing. So to exploit that correlation, we have to move up the ladder. We have to experiment with different types of machine learning algorithms. Even I'll say that neural networks perform really well when we will implement. If we go for advanced implementation, then we can see that other algorithms perform much better than Naïve Bayes. This is just a simple, very basic implementation. So you can experiment on your own. You can construct features like bag of words features or TF-IDF features. You can even combine the two. There are also n-grams. Have you heard about that?
Not yet.
Okay, so in n-grams, what happens is that here we are taking unigrams. You are considering single words. All right. So you are taking just one word, like the lion is the king of the jungle. So the lion is king of jungle. So these are single words. But if you want to see the sequence, so if we are taking n-grams, so n-grams can be n equal to 2, that is bigrams. So here in bigrams, you will consider pairs of words. All right. So the lion into one single entity, the king one entity, king jungle one entity. So the entire tokenization which we have done over here for bag of words construction, that takes only one word at a time. But when we are constructing n-grams, then we are including some additional information. We are also seeing what is the word previous to the current word that I am analyzing, right? So you can also take small sequences. So that is how n-grams approach is going to take place. So the main aspect is that you have to experiment with different features. You can combine these features. You can combine your bag of words feature, what you have obtained, and the TF-IDF features which you have obtained. You can combine them both and experiment how well it performs using some other learning algorithm. So a lot of prospects are there, a lot of experimentation is there when you're working with text data. So, and also like in images also, you convert it into a numeric form. You cannot feed in the images. So you have to consider a whole lot of computations and matrices and everything, which we will see in some other session if we have on CNNs. Then the same aspect is also applied over here. So for text also, we have to convert it into a numeric form. We have to experiment with different kinds of features. We have to see how we can extract the semantic information, the word-to-word relationships within the text. So over here in TF-IDF, which I just discussed right now, we are not even exploiting the semantic, the word-to-word relationships are not there, just the statistical information is there. So you cannot draw a lot of information using the basic level features right now. So it is only useful to learn these, but now a lot of advanced feature construction, advanced algorithms are there under research. So we shall also see them in some other sessions.
Okay. Yeah. Thank you, ma'am. Yeah, Divya Prakash sir, please mute me. My doubt's over.
Ma'am,
Yeah.
ma'am, we are taking the reviews, and as per whether the person has liked it or disliked it, we are taking it as like into absolute conditions. But the person may, like the different individuals may or may not like it to the same extent. So how do we
Yes.
cater for that?
So this is a binary classification task, right? So the one which I have discussed. So here we have only positive and negative sentiments given in the data set. It is a supervised classification task, but it is not necessary that your sentiment has to be in positive and negative. So there are many categories of sentiments. Okay, so there are even sentiments where you can say neutral reviews, like a person has an average liking towards a certain like certain movie review. A person has just like a negative also, within a negative review also you can classify it into different types. Someone has expressed his or her anger towards a particular review, that it was a particular movie in a review, like did not like it at all. So that is also, the extremes are there. So you cannot just take it as 0 and 1. For this task, for this very preliminary task, I have considered only a binary classification task. But when you work with real-time data, you cannot have a binary classification task. You have to have a particular, you'll have ranges of emotions or opinions, right? So you'll have from 0 to 5, you can have different kinds of sentiments. Then you have to design an algorithm to predict that sentiment. So when you are applying it to a real world scenario, then it may not be binary classification. You will have different kinds of different kinds of variations in sentiments. So you have to take all of them into account. You have to assign specific classes to all those different sentiments, and then you have to perform your task. So that is how it works.
Okay, ma'am. Thank you.
Yeah, thank you. Any more questions? Okay, does anyone have any doubt in the feature construction part? Like the bag of words model, which we discussed, and the TF-IDF vector construction. If anyone has any doubt, please feel free to say. So I'll go through that once again. Or even you can raise your hand. So I'll know, then I'll explain it once more time.
Ma'am, actually, you share the collab. We'll revise it once more and try and understand it. And once we do, then we'll ask the questions because it is a new concept. So we'll go through it once more.
All right. And the mathematics, the feature construction part, I hope it's clear then. All right. So I'll just go through the code once again.
Yes, please, ma'am.
Yeah. Is it visible? Is my Colab notebook visible?
No, ma'am. It's the PPT that is visible.
Okay. 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 I'll reshare it once more. Okay. All right. So first of all, the data set which I have shared with you is present in a folder in Google Drive. You can directly copy it into your own drive and then go and create a collab notebook. So go to collab.research.google.com. Over there, you can create, you can have your own working space, and you connect it to a backend, and then you can link your Google Drive using this icon over here. Right. You have this icon here. From here, you can mount your drive, and you'll have all the files accessible from your drive. Okay. Then get the link of the file where the dataset file which is present in your drive, and you can load it using pandas. So using the function pd.read_csv, you can directly load your dataset and check whether the dataset loading is successful or not, and then you just print that shape of the data. You can explore your data. So data.head function will print the first 5 rows of your dataset. Um, so has everyone been able to copy that folder?
No, ma'am.
No. Okay, no problem. I'll share the complete notebook and everything. I'll just walk through the code.
How you showed that we can access a drive document?
Okay, so over here you have this particular icon, right? So from here, from files, after you click on files, you can mount your drive using this icon. So if I create a new collab, uh, if I have a new collab document, so from here you can create a new notebook. You have the option to create a new notebook. You click on that option. So no installation of Python is required. You can directly access all the everything from the web using your browser. And this is yeah. So here you have your own collab notebook. Then from here you have to click on files. So it will connect to a runtime, a virtual a backend from where you can load all your Python files. Yeah. So over here you have the option to mount the drive. Just click on that. You have to give permission to access your Google Drive files. Then you connect to Google Drive. So if you have copied the dataset folder to your drive, then it will appear in your shared folders. So you can just go there and get that file. So a lot of yeah, so all your files will appear. So you just see in which folder you have copied, and from that you can just get the link, the path to your data set, and you can just copy it, and it will load it using pd.read_csv function. Okay, so that is how we load our data set. We can explore your own data, whichever way you are. You can also load your data. So if you're not able to link it via Google Drive, then over here you have the option. So whatever file you can use you can upload your file. So from your local disk, if you are downloading the dataset file, then you can directly upload it to your Colab also to work with it temporarily. And yeah, so here we were exploring different reviews. So And yeah, I had also gone through the generation of word clouds. So it's just a um, distribution of the text uh, within the particular review. Then we performed text preprocessing. So these were the 5 steps that we performed. First, we went through lower casing of text, then punctuation removal, tokenization, stop word removal, and stemming. So in lower casing, we are just converting whatever text we have. We are simply converting it into lowercase letters. We are removing the punctuation because they have little or no semantic weight. In our case, we are considering that punctuations do not hold any semantic significance, so we are removing them. Tokenization, as in we are separating the words into different tokens. So if we have a given a long string, then on the basis of space also you can split the string. You can use the string functions that will, if you find it simple to work with strings, then you can use your the string.split function to perform tokenization. Then we go through stop word removal. So in NLTK, you can access the list of stop words. So in entire of English, in English, whatever stop words are, whatever words that are considered to be stop words, I, me, or, and, not. So all those stop words will be included in that list. Also, you have the option to create your own list of stop words. So many a times whenever your application requires that, then you can add your own stop words or you can remove the existing stop words. Like for example, if you are performing some like information retrieval and you want to have a query from the user, so in a search engine suppose, and someone is searching for artificial intelligence and machine learning, so in that case the word and becomes important, right? So you have to take into account and as well. So in such cases, the stop word removal is done in a different kind of manner. So when you are processing user queries, we are also taking into consideration the conjunctions. So and means that both of them should be present in any document if we are searching. So like that. So it depends on your application whether you will which step you want to perform, which step you do not want to perform. And we also go for stemming over here. So stemming, that is, we want to find out the root word. So if we have different words like running, runner, runs, so all of these words will be reduced to their root form, which is run. So like that, stemming will help you to remove the inflectional endings. Yes, but there is also, I'll also say, there's one problem with stemming is that if you have words like computer and computing, so what it will do is that just to normalize the words, it will reduce it to compute. So it will be CUMPUT. So that is not an English word, but just to normalize, just to reduce the words to their original root form, what stemming does is that it reduces the inflectional endings. So basically it will chop off the words. So in that case, if it's such occurrences, if you do not want such occurrences to happen, then you can use, there's another technique called lemmatization. So in lemmatization, what we do is that we obtain the dictionary form of the word. So in such a case, if you have computing and computer, so what lemmatization will do, it will reduce it to compute. So it will follow the grammar, or you can say it will follow the dictionary, and it will also see the part of speech is that whether it is a noun, a verb, or an adverb, or an adjective. So like that. So a lot of considerations are there. So in any subsequent session, we will also see in depth more concepts. So these are just the basic concepts that I have touched in this session, but a lot of things are there to yet to explore. Yeah. So over here you can see we have used NLTK library, and here just to set up the Colab environment, we have to use this. So NLTK.download punct, then NLTK.download stop words and wordnet. So if you want to, whatever the tools you want to use. So this is just a general libraries that we need to work with text. So I have imported all of them together. So yeah, so we are using Porter's stemma, and stop contains the list of stop words, punct contains the list of punctuation. Then we go to the first step, which is lower casing. So over here, I have applied the lower str.lower function to the entire column. So data review is actually, we are taking the entire column, that particular reviews column of your data set. And then we are applying, collectively applying the lower casing function to all the entries in that particular column. Okay, so this is kind of collective way to, you can also use a for loop. You can simply loop over all the different entries in that particular column, but this is just a collective way to apply a given function. So here you also have, here I have used regular expressions. So here I am removing all the non-alphabetical characters. So this character stands for not. Okay, so this one means whatever is not A to Z, that will be removed with a blanks. So whatever, wherever anything occurs that does not lie in A to Z range, that is not an alphabet, all those will be removed, and we will have a single blank space over there. So that is the way we can perform pre-processing. And after that, after we have cleaned it, after we have lowercase, and after we have removed all the non-alphabetical characters, this is how our review appears, right? And after that, we perform a word tokenization. So the entire string we feed in, and we get a list of tokens. So each and every word in the list is actually a token. And token, or you can say each and every, you can also call them as unigrams. So this is a unigram approach that we are going to use in our bag of words feature construction. And this is stemmer, Porter's stemmer we are using. And we are cleaning, we are obtaining cleaned tokens. So whatever word that is not a stop word, so we are actually filtering through the list of stop words, and the words which are not in stop words, so those are the words that we want. So that words we are performing stemming on those particular words and adding it to our list of cleaned tokens. Okay, and after that, we have the list, our data set, which is actually a cleaned data set, and the respective sentiments, labels we have. Then I also told you that you can uh, just store your intermediate files. So whatever file you're pre-processing, so pre-processed data, you can just directly store it using the pickle. It is a very useful library, so keep it handy. And whenever you want to work next, so all your pre-processed data will be stored, and you can directly load it using pickle.load function and use it again. Then we move to bag of words. So bag of words, we apply bag of words feature, to obtain bag of words feature vectors, we use this count vectorizer library, which is available in sklearn. And we also here we have worked with multinomial Naïve Bayes, which is a very primitive, sorry, I'll say a baseline model for our task. And first you will split your data set into train and test, and then you will use the count vectorizer to obtain the feature. So here what you are doing is you are initializing your count vectorizer and to have 10,000 entries. All right, so here your vocabulary size is 10,000. Then we fit the vectorizer to the training set. So whatever train data you have, so you have to fit your, so whatever vocabulary will be formed, that will be done using your training data. And after that, when you are creating bag of words features, so whatever words are in your train set, so that will form your vocabulary. And after that, when you are creating the vectors, you will collectively create the vectors. So for train also, for test also, we are via transform function, you are actually obtaining the individual vectors, and you'll get the output as in the form of a sparse matrix. And when you apply the function to array, to convert the sparse matrix into a NumPy array. So sparse matrix, you cannot apply it to your learning algorithms. You have to convert it into a NumPy array. So that is how your machine learning algorithms will work. Otherwise, it will give an error. So always remember to convert it. And you can check the shape of your arrays. And this is how your array actually looks like. So whatever words are present in a particular document or in a particular review, those particular words will have the frequencies. The particular frequencies will be mentioned in that list of in the vector. Then we move to model training, and in model training we use multinomial Naïve Bayes, and here you create an instance of the particular from the library which you have, and we perform fit function, and on xtrain the feature construction which you have done and the labels which you have. Then you perform prediction on the same, and using the metrics, you can evaluate how well your model has performed. So over here with bag of words, we got 84%, and you can evaluate using classification report is also present, and using TF-IDF feature vectors. We also carried out the same experimentation using TF-IDF features, and here we got around 83.6 accuracy. So it's around quite same in this case, but if we apply some better algorithms, so instead of this baseline, if we go for better algorithms, you can try with decision tree. For instance, you can try with random forest, you can try with multi-layer perceptron. So as an introductory session, I considered a multinomial Naïve Bayes, but you can experiment on your own. So it's very good if you can improve this accuracy, if you can experiment with different feature constructions, right? So you can also have, you can experiment with n-grams. So in TF-IDF vectorizer, you also have, in all the vectorizer, you also have the option and to specify n-gram range. So you can have the n-gram range, and here you to specify the n-gram range. So suppose you want to work with bigrams. So bigrams means sequences of 2 words, 2 tokens at a time. So in order to specify bigrams, you'll write like n-gram range 2,2. If in case you want to take into consideration unigrams, that is single words, as well as bigrams, then you will specify it as 1,2. Okay. And if we want to work with trigrams, then we will specify 3,3. So whatever you want to work with, you can experiment on your own, and you can see how the performance measures, how different algorithms and different feature constructions can work can improve the efficiency of this single task. So on this single data set, you can perform a lot of experimentation. Right. So anyone has any questions, you can still ask me. You can raise your hand if you have any question. Okay, I'll just share the collab. So you all can go through the code segment and you can experiment on your own. You can work with different kinds of algorithms. So you can study if you already have some experience in machine learning, then you can go for some advanced algorithms to work with. And you can also construct different kinds of features. And in subsequent sessions, if you conduct subsequent sessions on natural language processing and text mining, then we shall be discussing a lot more. And we'll also learn how NLP has progressed into using with deep learning. And we'll also see a lot of applications. So right now, as of now, all the research that is being done in the field of natural language processing, it has actually become a part of the deep learning community. So we can also go through a lot more applications. So it's not just sentiment analysis. We can also go through information retrieval and information extraction, chatbots. So I hope you all had a good learning experience in this session. And still, if anyone has any questions, you can always you can just raise your hand. We'll unmute you and you can ask.
Yes, Shivam, you can unmute yourself. Actually, we have unmuted all of you.
Yeah, ma'am, wanted to
Yeah,
ask what will be the best activator function if for the output layer if I am performing a multi-class classification?
for multi-class classification, you can use softmax.
Softmax, okay.
Yeah.
Yeah, thank you.
Any more questions?
Also, you all drop your experience on the chat box, means a like or something like that. How you enjoy the session. We would appreciate that.
If you also have any difficulty in understanding any concept, then you can even personally message me or mail me. And if you want to explore other areas of NLP, then also you can contact me. I'm really enthusiastic about working in natural language processing, and I've previously worked in NLP. So I really like to explore a lot more, many more applications. So drop your comments, or any suggestion that you have, how we can, if we can improve our session. Thank you, Shivam.